Okay, now it's time to start some addition and subtraction of radicals. Now, in the last section, we did simplifying radical expressions, and so that's going to become important to be able to do some adding and subtracting, because adding and subtracting of radicals is very similar to adding like terms. And remember, when we add like terms, the terms had to match. So in like terms, you had to have the same variable with the same exponent. With radicals, you have to have the same root in order to be able to add or subtract them. And then what you will do, you will add or subtract the number in front of the root. Similar to, very, very similar to collecting like terms. So the example shows you've got 3 fourth root of 5 plus 4 fourth root of 5. Those are both fourth roots of 5, so then we can add the 3 plus the 4 to get 7 fourth roots of 5. So let's look at some of these down at the bottom of the page. If I've got a square root of 6, there's an imaginary 1 in front of that square root of 6. So a 1 square root of 6 plus a 2 square root of 6. Add the 1 plus the 2. That gives me 3 square roots of 6. Okay, not too bad. In the next one, I've got 5 cube root of 3 minus 6 cube root of 3. Again, they're both cube roots of 3. 5 minus 6 would be negative 1 cube root of 3. Okay, in this next one, I've got all square roots of 3. So 4 minus 2 would be 2. 2 minus 8 would give me negative 6 square root of 3. Now notice, all of these so far have been square roots that would not simplify underneath the root. So that's something you're going to have to check on, and we'll get to those in just a minute. Okay, in this next one, I have 2 of these that have square roots of 5 and 1 that has a square root of 2. I can only combine the ones that have the square root of 5 with them. The 2 square root of 2 is just going to get stuck onto the end. So 7 square root of 5 plus 3 square root of 5 would give me 10 square root of 5. And I can't combine the 2 square root of 2 with anything, so it just stays a minus 2 square root of 2. Similarly, in this next one, I've got fourth roots of 7 with 3 of the terms and then a minus 2. So that minus 2 is not going to get combined with anything. I've got 9 minus 4, which would be 5. 5 plus 30 would give me 35 fourth roots of 7, and then a minus 2 at the end. Okay, so you have to have like roots to be able to combine them. Now, what if we don't have like roots to begin with? In this example, I'm going to do it kind of like I would have done it, which is a little bit different from their explanation. They've got 11 and then fourth root of x to the 7th minus 3x fourth root of x cubed. All right, so I look at each of these. They don't match. I've got an x to the 7th under one and an x cubed under the other. But I'm going to look and see if I can simplify. So the highest number that goes into below 7 that 4 will go into would be x to the 4th. And so that leaves me x cubed left over because 4 plus 3 is 7. The fourth root of x to the 4th is an x to the 1 because 4 divided by 4 is 1. And then the x cubed will have to stay. So I have 11x fourth root of x cubed. Well, now if you look at the second term, it's a fourth root of x cubed. So now they match. So minus 3x fourth root of x cubed. Now, it just so happens that I can take 11x minus 3x. That would leave me 11 minus 3 is going to give me 8. Well, let me erase that. That's kind of messy. That's going to give me 8x fourth root of x cubed, because 11x minus 3x. Now, suppose we had 2 cube roots of 3 minus x cube roots of 3. Well, those are both cube roots of 3. 2 minus x, you can't combine and get a 2x out of it. That would be 2 minus x in parentheses cube roots of 3. Not sure if you're going to have any like that at homework that don't combine once you do your simplifying, but just in case you will have seen an example of that. Okay, let's look at some of these now. These next 4, you're going to have to do some simplifying before we can combine them. Because notice in this first one, I've got a cube root of 8x and a cube root of 125x. You can't combine those as they are right now. So I'm going to look at 8, and again, I'm going to have to pull out that perfect root page that I have given you that you need to print off because that's going to help you simplify these. So I'm looking at cube root of 8. Well, the cube root of 8, 8's a perfect cube. It's going to come out as a 2. So I'm not going to have any number left over, and then I'm going to have this x left underneath, okay, because it doesn't come out because it's an x to the 1. Now, this is something we've not really dealt with before. We have a number that we brought out, 2, and we already have a number in front of the root. We haven't really talked about that. If you bring out a number from underneath the root and you already have a number in front, you're going to need to multiply those two. So 5 times 2 is going to give me 10 cube root of x. Okay, so if I bring something out, I'm going to multiply it times the number in front. 125 is not a perfect cube, but, well, yes it is. I'm thinking perfect square. 125 comes out as a 5, and the x will stay. So 5 times 5 in the front will give me 25 cube root of x. So now I've got cube roots of x. So 10 plus 25 gives me 35 cube roots of x. Okay, let's look at the next one. It's square roots again. I can't simplify square root of 2a at all. That's as simplified as it goes. There's an imaginary 1 in front that I won't forget. Then I'm looking at 4 square root of 72a. I know that 9 goes into 72 8 times, but I'm thinking there might be a higher perfect square that goes into 72. So if I go down through my list, I'm going to check 16, I'm going to check 25, and when I check 36, 36 is the highest root that goes into it, and it's 36 times 2. So 36 comes out as a 6. I already have a 4 there. So from the beginning, I have a square root of 2a, and then I've got a 4 times a 6, so minus 24 square root of 2a. Now let's look at this last one. 8 has 4 in it, so 4 times 2 is 8. The 4 will come out as a 2. This 2 will stay. I already have a 4 outside, so 4 times 2 will give me plus 8 square root of 2a. So now all of these are square roots of 2a. Remember, there's an imaginary 1 in front of that first one. So 1 minus 24 would give me negative 23. A negative 23 plus 8 would give me negative 15 square root of 2a. I hope you're kind of understanding how we do it. I know it's fairly easy if the roots already match, but if they don't match, they wouldn't give you a problem where something's not going to match. You're gonna find some combinations that will end up being like terms. Okay, let's look at this next one. We're back to square roots again now. 150 is not a perfect square, but 25 goes into it, I believe 6 times. So the square root of 25 is 5. This 6 will stay. Now let's look at our letters. X squared, remember there's an imaginary 2 in this root. So 2 divides by 2 1 time. So an X is coming out. And then the Y has to stay underneath. So I have a 5X that came out. I have a 6Y that's staying underneath. Okay, and for 600, I know 100 times 6, and 100 is a perfect square because it comes out as a 10. Now I have a number in front of there. So I know 19 times 10 is going to give me 190. Let's see what else we have. We have an x squared, and there's an imaginary 2 there. So it's going to come out as an x because 2 divided by 2 is 1, and the y is going to stay. So I brought out an x, and then I have a 6y that's staying. Again, these roots match now because I have a square root of 6y in each one. So 5x plus 190x is 195x square root of 6y. Okay, last one. We've got a 45. That's going to be 9 times 5. The 9 comes out as a 3. I already have a 9. So 9 times 3 would be 27. 5 stays underneath. So I would venture to say that the rest of these are going to have a 5 that stays underneath. 125 is 25 times 5. A 5 comes out. 5 will stay. 9 times 5 will be minus 45 square root of 5. Then I have another minus. 80, that's 8 times 10, which is probably what most of you will think about when you first think of 80. But 8 is not a perfect square, and 10 is not a perfect square. So that doesn't really help me a whole lot. So I'm trying other numbers. 4 times 20, so 4 would work, but I think there's a higher one. I believe 16 goes into 80. 16 goes into 80 5 times. So 16 comes out as a 4, and I have a 5 left. And then I already had an 8 to begin with, so that's minus 32 square roots of 5. So let's combine these. 27 minus 45, that would give me negative 18. And then a negative 18 minus a 32, that gives me negative 50 square roots of 5 in all. So that is how you are going to simplify when you're trying to add or subtract radicals. Make sure your radicals match. If they don't match, see if you can simplify in order to kind of make them match. Sometimes you may have matching, sometimes you may not. Once you've simplified, then you just have to simplify it, and you don't get one root for an answer. You may have an expression left. Email me with questions. Y'all have a good day.